Ever seen something out of a sci-fi movie and thought, that's impossible? Well, what if I told you the future is already here? We're talking about materials that don't just exist. They react, they heal, and they adapt. Imagine a world where your phone screen fixes its own cracks, your clothes change color with the weather, and robots are as soft and flexible as living creatures. It's not science fiction. It's material science, and it's about to blow your mind. Let's dive into the top 10 smart materials that are literally shaping our future. First up, shape memory alloys. These are some of the most fascinating metals you'll ever see. You can bend them, twist them, crumple them into a ball, and with just a little bit of heat, they snap right back to their original shape, as if they have a memory. Think about eyeglasses frames that you can't permanently bend out of shape or stents used in. Surgery that can be inserted into a blood vessel in a compressed form and then expand to the perfect size once they reach body temperature. It's like a magic trick, but it's pure science. These alloys are already being used in everything from aerospace components that deploy in space to everyday consumer goods. Next, let's talk about something truly revolutionary: self-healing polymers. Picture this. You get a nasty scratch on your car's paint job. But instead of a costly trip to the body shop, you just wait a few hours and the scratch vanishes on its own. That's the power of self-healing polymers. These incredible materials have a built-in ability to repair damage. When a cut or crack occurs, it triggers a chemical reaction that fills the gap and bonds the material back together, almost like how our skin heals. We can literally cut a piece of this material in two and watch it mend itself back into a single piece. The potential applications are huge, from phone screens that never stay cracked to coatings that make our infrastructure last longer. Coming in at number 3 are thermochromic fabrics. Fashion meets function with these amazing textiles. These are materials that change color in response to temperature. You might have seen them in mood rings or color-changing mugs, but the technology is becoming much more sophisticated. Imagine a t-shirt that changes its pattern when you step out into the sun, or a baby's onesie that changes color to signal if the baby has a fever. Beyond just looking cool, these fabrics have serious safety applications. Firefighters' uniforms could have patches that change color to warn them when external temperatures are dangerously high, providing a crucial immediate visual cue in high-stakes situations. It's a simple, brilliant way to communicate information without any electronics. At number 4, we have piezoelectric crystals. This one sounds complex, but the concept is beautifully simple. These materials have the unique ability to generate an electric charge when you apply mechanical stress to them. Squeeze them, press them, or even just vibrate them, and they produce electricity. Conversely, if you apply an electric voltage to them, they change shape. This two-way street of energy conversion is incredibly useful. You've probably used this technology without even knowing it. It's in the igniter of your gas grill and in the sensors that deploy a car's airbags. The future could see these crystals embedded in our roads to generate power from traffic, or in our shoes to charge our phones as we walk. We're just getting started on this journey into the materials of tomorrow. If you're finding this as cool as I am and want to see more deep dives into future tech, do me a huge favor and hit that like button and subscribe to the channel. It really helps us out and ensures you won't miss what's coming next. Your support makes these videos possible. Alright, let's get back to it. Our fifth amazing material is electroactive polymers, or EAPs. If piezoelectric crystals are the sensors, EAPs are the muscles. These are polymers that change their size or shape significantly when stimulated by an electric field. This property has earned them the nickname artificial muscles. When a voltage is applied, they can bend, expand, or contract, mimicking the movement of biological muscles, but with a much simpler mechanism. This technology is at the forefront of soft robotics, allowing us to build robots that are flexible, gentle, and can operate safely around humans. They're also being developed for medical devices, like tiny pumps inside the body, and even haptic feedback systems that let you feel virtual objects. Number 6 brings us to hydrogels. These are networks of polymer chains that are incredibly absorbent, capable of holding huge amounts of water. You might be familiar with them from contact lenses or disposable diapers, but advanced hydrogels are so much more. They are smart because they can be designed to react to specific stimuli in their environment, like changes in temperature, pH, or moisture levels. For example, a hydrogel in a bandage could release medicine as a wound heals and its chemical environment changes. In agriculture, they can release water to plant roots only when the soil becomes dry. And in robotics, they're being used to create soft, water-based robots that can navigate delicate environments. At number 7, we have the superstar of materials science, graphene. You've probably heard of it, but its properties are still mind-boggling. It's a single layer of carbon atoms arranged in a honeycomb lattice. What does that mean? It means it's about 200 times stronger than steel, yet incredibly lightweight and flexible. It's also one of the best conductors of electricity and heat ever discovered, far surpassing copper. Graphene has the potential to revolutionize almost every industry. We're talking about ultra-fast computer chips, super-efficient solar panels, incredibly strong and light composites for planes and cars, and even advanced water filtration systems that can desalinate seawater with minimal energy. The age of graphene is just beginning. Number 8 is a mouthful, liquid crystal elastomers. Think of them as a hybrid between the liquid crystals in your TV screen and a rubber band. These materials can undergo massive, reversible shape changes when exposed to stimuli like heat or light. Shine a specific wavelength of light on them, and they can be programmed to bend, twist, or crawl. This makes them perfect for light-activated soft robotics. Imagine tiny, untethered robots that can be controlled simply by shining a laser pointer, allowing them to perform tasks in hard-to-reach places. They could also be used to create self-actuating surfaces, like window blinds that automatically adjust to the amount of sunlight. For number 9, we're entering the world of magnetorheological fluids. These are oils filled with tiny iron particles. Under normal conditions, the fluid flows like any other liquid. But when you introduce a magnetic field, something amazing happens. The iron particles instantly align, and the fluid transforms into a near-solid, jelly-like substance in milliseconds. The strength of this solid state can be precisely controlled by adjusting the magnetic field. This technology is already being used to create advanced shock absorbers for high-performance cars and prosthetics, allowing for real-time adjustments to changing terrain. It's also used for polishing and vibration damping in precision manufacturing. And finally, at number 10, we have bioengineered silk. We all know silk is strong, but what if we could make it even stronger? Scientists are now using genetically engineered bacteria to produce silk proteins. This allows them to create silk that is not only more consistent than what spiders or silkworms can produce, but also stronger and more elastic than Kevlar, the material used in bulletproof vests. This bioengineered silk is also biocompatible and biodegradable, making it perfect for medical applications like artificial ligaments, tendons, and sutures that are incredibly strong, yet can be safely absorbed by the body over time. It represents the perfect fusion of biology and engineering. So there you have it, 10 materials that are blurring the line between science and magic. From metals that remember their shape to fluids that turn solid with a magnet, the future is being built from the molecules up. Which one of these smart materials absolutely blew your mind? Was it the self-healing polymers or the bioengineered silk? Let me know in the comments below. I read every single one, and I'll be revealing even more incredible technologies in the next video. Thanks for watching, and don't forget to subscribe so you can join me on the next adventure into the future.